Hello everyone on YouTube, it's Rawze from Rawze.com here. Figured I'd make a little different kind of video this time. I usually make truck videos, but make something a little different. I have a mini tank robot. One of these Key Studio, I don't know, looking things. Somebody sent me on the forum there last Christmas. I've been playing with it. And it's one of the little robots that runs and down, runs around, and it's got little eyes that looks around. And they asked me if I'll make a video on how I would program this thing. You know, I was like, you should make some programming videos. You know, you always complain about people's programming and this and that and the other, you know. So I thought I would make a video on programming this thing. It's a very simple toy. Kind of reminds me of the automation stuff I used to do back in the day. So, you know, I have a little different mindset, I think, than most programmers do. I'm sort of hardware oriented. And how would I program this from the ground up, not knowing anything about it? I guess that's where I would start. Well, I have to identify the thing. First, it's a mini tank. And then the mini tank has two sets of tracks. They go forward and reverse, obviously. It's got a set of eyes. More like a sonic sensor, a transducer and receiver. A little stepper motor to make it look back and forth. Pretty straightforward to me. And the two tracks, each track is made with looks like a bidirectional DC motor, variable speed probably controller. So I got two of those. I got a stepper motor, or angular stepper motor actually. It's an angular stepper motor because it goes at an angle, probably program it angularly. Looks like it goes from 0 to 180. Yeah. 90 would probably be facing forward. And yeah, sonic sensor. So there's a few pins. Got an Arduino chip on there, Arduino board, Uno looks like. It's got a few pins. How would I program this thing? How would I go about it? You know, there's a program that came with it, and I took a look at it, and it's quite bad, actually, in my opinion. I mean, it works really good. There's nothing, you know, the program actually functions correctly, but it's like out of date A to Z style programming with a lot of sub functions, and it's hard to follow the program. It's written in C++, you know, the language I prefer to the Arduino, I guess, and it's just terrible. Instead of digging into that program and picking it apart or picking on it, why don't we use it as a reference to find out what pins are connected to what? We can do that and then start from nothing. I think that would be a better option. And program it the way I would program it. So let's go over to the computer and play with that. Cut. Okay, so now I'm on my computer and I'm not real good with all the screen and all the different professional things, the tools that YouTuber guys use, or, you know, these guys that make their videos professionally do. So I got a really cheesy USB camera and the sound on my computer here, and I think it'll get the job done. So I'll minimize me and go back to working on this mini tank project. First thing I would do is identify programming wise what I would want to do to this thing with a block diagram. So I would bring up something like LibreOffice Draw or something like this, and maybe draw a big square and call it mini tank. What do you think? Mini tank. That's what I'm going to call it. And then of course we identified that it had a set of eyes, and we'll do that, and we'll change the color, make it look pretty. Give it a green. What do you think? Oh, that's the border color. Green. And then of course it has a set of tracks. And obviously the eyes are connected or are part of the mini tank, and the tracks are connected to and or part of the mini tank. And now we have some hardware components. And I think I'll color those red. We have according to that mini tank, we have a sonic sensor. That's what it said. That's what we determined. And we'll change our text to upper left corner. Of course, a sonic sensor has to have, as part of its hardware, a transmitter pin on the Arduino, or transducer pin, and then obviously a receiver pin, one of the pins on the chip, on the Arduino board, chip board, whatever you call it. Okay, we have a sonic sensor, and then we're going to have an angular stepper motor, obviously. Angular stepper. And of course, it's going to have a control pin. PWM, probably. That's what I remember, right? And then those two things obviously make up the set of eyes, or it looks like a set of eyes. It's actually not eyes, but we're going to call it eyes because that's what it looks like. All right. And then of course we have a bidirectional motor. And of course, the motor is going to have a direction pin, likely, and it's going to have a speed pin to control the speed, what direction it goes and what speed it goes. Of course, I have two of these, and we will say that this one is the left one and that this one is the right one. There we go. And obviously the two motors are what makes up and is connected to the tracks. There. Looks like a pretty good program to me. Over here in this area you have your hardware, you have your identified objects that make up the device, and of course the main device itself. That's how I would program it. Pretty simple. I'm going to go ahead and start doing this. Now, the language of the Arduino is C++. And I have here, I created a new project in Eclipse. I use Eclipse for my Arduino stuff. It's a little bit better than the Arduino programming suite, I guess, that comes with Arduino. A little bit better quality integrated development environment. It has a lot of helpers in it versus the Arduino editor, where you can right-click things and you can look them up, and a lot of auto lookup and auto-complete and things like that to help you write cleaner code and to help keep you from making mistakes with your program. So the Arduinos usually come with this Arduino.h library. That's what defines like pin mode and all the different things people talk about on the different YouTube channels and the different instruction websites and things, how to program Arduino, digital read-write functions, how to turn on and off things, how to control lights and switches and motors and literally everything. Arduino with the pre-made libraries. So that usually gets included at the top of the program. If you're using the Arduino editor, you don't need to include that. It'll automatically include it. But with anything else, any third-party editing software or program creation software, you usually have to include it, and I do here. And all Arduinos typically recognize a setup program or a setup function and a loop function. Setup basically, it runs one time when you turn the thing on. Flip the power switch, the setup runs, and anything inside these brackets it will do. And then the loop is a simple loop that just runs forever. Once it runs setup and it gets done with that, it jumps into the loop, and then it just runs in a circle, round and round and round, and it goes until you turn the power off, endlessly. And everything inside these brackets, it obviously will do, any commands or functions or programming that you do. So that's pretty simple for the Arduino side, but now we've got all this, all these different things here we have to put in. So how do we do that? Well, I will assume that people watching this video aren't professional programmers or aren't programmers at all. How about that? That they're people from my forum and they drive trucks and they want to learn a little bit about Arduino and a little bit about C++ programming. So I'll start there. And for the rest of the world that knows a little bit about C++ and programming and Arduino, they're probably going to get bored real quick here. Just warning you. So what would I do to program this? Well, I'm going to program it in C++, which is the language of the Arduino, most of these Arduinos. And that's obviously the program that came with it, which is terrible. And the reason why I call it terrible is pin LB 12, define 12, pin LB. What is this? This tells me nothing. This is the top of the program too. And as I go down through here, pin mode, LRB output, FB, LB output, input pin. This is not English. They're English words, but this is not English. This is not something a human can readily read. My background in programming, I was always taught, and I always tell others, the purpose of a programming language is for the human, not the computer, literally. I mean, that's the truth of it. Why would you have a programming language if you understood what the computer wanted and could program in the computer's language? You wouldn't need a programming language. You wouldn't need a translator. You could just program it in ones and zeros. But, as people, we're not good with that. So we need something to translate what we have in our head and what we want to say and what we want to do into something that the computer can translate into ones and zeros and bits and bytes and obviously, different data types. So C++ is a powerful language. It's a good language for that. But people, I think, very quickly, programmers especially, I think, very quickly, they try to think like the computer. And they program in what I call programmerese. And I don't agree with it. And that's one of the problems I see with a lot of the programs I see, especially nowadays. You see all over the internet, you see people doing tutorials, and you see people doing all these things, and they're trying to teach you programmerese. They're not trying to teach you the language on how to translate that from what a person would think and how a person would do things to what the computer needs. That bridge between the two, I think, is too easily lost, because everyone assumes you're going to learn the syntax of the language, which is where the brackets go and what this means and that means, and you're going to think like a computer after a while, and I think that's wrong. I think, especially with this Arduino stuff, the Arduino stuff, it's a microcontroller. It has very limited RAM. It has very low programming space. If you keep all that in mind, when you program, especially in C++, because C++, very easily you could eat up all the RAM, or you could eat up all the programming space, because you can make things too elaborate really fast, or use arbitrary, data types and places of memory storage that just eat the thing up and unnecessarily. So that has to be kept in mind when you use this language. So I'll try to keep that in mind as I go along too. So how would I explain this programming language to somebody on my forum that wants to play one of these robots and learn a little bit about Arduino has no idea what C++ is for the most part. I think that's what I'll do next, is I'll explain some of this stuff. So, at least with my perspective, I'm not a professional. I've never been a professional programming engineer, but I've had to do a lot of professional programming over the years because I'm always dealing with that interface between hardware and software. So I've always had to do a lot of it. So I'm going to create a new file, and I'm going to give it just a C over template so that so I get the right highlighting. I'm going to blank it out. What is C++? Well, how do I get familiar with C++ enough to program that robot? You know, if I'd never used the language before, I would have, obviously I would have to identify its syntax and all this stuff, probably look up a bunch of stuff. But understanding how the language works is probably the most important thing, and understanding what you want is even more important than that. Never think like a programmer when you want something. You should think like a person. And if you do, complexity is where you get yourself if you think like a programmer. Every programmer, or most programmers that I know, or every programmer that I've seen that has problems with complexity, always box themselves into a corner. And it comes from thinking like a programmer instead of thinking like a person. If you think like a person and you program things in the right ways, and you learn how to put things in the correct perspective for the world and your life, and something like this robot, or it's real simple, or something super complicated, if you look at it in the right perspective, then there's really no limits to what you can do. And C++ is a good programming language that portrays that or shows that. I mean, most everything, all your more advanced languages are usually done in C or C++ or C# or a variation of C. And that says a lot. Entire operating systems, the kernel that runs the core of your processor, the software that runs the screen on your computer. I mean, literally everything most of the time gets translated down to C or C++ or C# from some other language down to that, or was done in that language, in that C language, or their derivative of, all the way down to the machine code. So it's a good language to learn. It's one of the more powerful ones. But one of the things that gets people is this A to Z mantra, or this function. Oh, I got to have a function for this, or a sub-module for that, and all this stuff, and it just confuses them. As far as complexity goes, I used to deal with a lot of things that were super complex at times. Think about, just coming up with an example off the top of my head. Think about the USA. Okay, I live in the USA. Think about the USA. The USA is a country, and it has states, it has cities, it has highways, it has sub-roads, it has streets, it has neighborhoods, it has counties, it has courthouses and buildings and people and cars and dogs and cats and plants and trees and flowers and soil and air and everything else. Imagine having to program everything all the way down to an atom about the United States in a computer. It sounds like an overwhelming task, and all of its functionality, like people walk, the cars drive, the wheels turn, the lug nuts hold the wheels. Think about how complex that would get really fast. Now, if you think of it as a human, as a person, most people, if you say, I live in the USA, I live in the state of Georgia, I live near the city of Atlanta, which I do. I drive a green car, I have this kind of dog, I wear these kind of shoes, I like to make this kind of things. Very quickly, someone that doesn't know you suddenly knows something about you, and they suddenly know that, okay, he's this and this and this and this, and that you can follow that in your head. You should program the same way. You should teach your computer or your device, or like say that little robot, in the same method, because if you don't, it'll overwhelm you. If you have to write 10,000 lines of code, of machine code or programming code to get something done, and it's super complex, if you did it thinking, okay, this has got to do all these things, and this one has to do all those, and this one after a while, after you're 5,000 lines of code into it, you don't know what you did 3,000 lines ago. And it gets to where you can't retain it in your head. You can't retain every person's name, like say in the state of Georgia. You can't go look in the phone book. Most people, savants can do these things, but most normal human beings can't look in a phone book and just read through it one time and remember all that stuff, and be able to reference every name, every address, every phone number, and just go and grab a phone and say, I want to call up Joe whoever, and without having to go look in the book again. And that's where programmers get themselves, because they make things so complicated that they can't find where to go get Joe out of the book, out of this, and look for that and then phone number, because they buried themselves so deep in this other stuff they've been doing that they get lost. So if you gear your mind around programming, around teaching your computer how to do something in a programming language, in the same way you would tell somebody on the street where you lived and who your neighbor was and what kind of shoes he liked, then you'd be much better off, because A, you could read what you wrote without having to comment the crap out of it. It would make more sense, and it wouldn't be so confusing. And you could find things, if you needed to get down to a gritty detail, you could find it pretty quickly and easily, and work on those details individually, and then move on. Once you have something established, you move on. That way you don't have to worry about it again. And that's kind of the attitude I take, and that's exactly why I came up with this block diagram. That's how I came up with the block diagram. I always take the top-down approach. I have a device. A device has, some components. These components are made up of some real hardware connectivity to the world, and those are these things here. And that's all that thing has. But think about something like an engine, or an entire vehicle, or a piece of automated machinery that makes robots, with all these robotic arms and stamps and presses and conveyor belts, and this is exactly how you would approach those things too. Just down you go in a pattern. And if you look at it this way and program it this way, then you don't get lost. So that's number one. What people should try to learn is never look at a program and say, I got to do this, and I got to do this, and I got to do this, and I got to do this. Never start your approach with this. Always start your approach with, okay, I have this, it contains this, it's made up of these have abilities to do this and this kind of stuff. But don't overcomplicate it. See, I made it very simple here, and that's all you really need is very simple stuff when you break it down. So how does C++ work? C++, now, I've read a lot of books. I've done a lot of programming in C++. I've never been professionally trained in C++, but a lot of guys like me, they know how to get around. So I have a different perspective than a lot of programmers do that are trained and professional and have all this super education on just programming. I've always been the type that I have a task that I have to perform, and I've got to get the job done. Now, when I was in my younger days, I used to hack through the programming language just barely enough to get it working and making sure that it didn't have problems. But as I went on, I got better and better and better. And I learned some things, and I learned a lot of different languages along the way, because it wasn't my only programming language. And so how would I explain, if I didn't know anything about programming much, how would I explain C++ to somebody? Well, first thing I would tell you, the first thing that comes in my head would be it's a contextual language. In other words, it likes to everything in a context. And that's actually good for the scenario that I just described about, super complicated things. And what I mean by context is, we'll look here on the screen and we'll say this is a context. Anything inside a set of curly brackets in this programming language is a context. Anything in here, we do stuff. We make, lines of code that actually perform tasks or store data or calculate data or manipulate different things, or maybe we send a control logic signal out one of the pins of that Arduino chip to turn the motor on, or we do all this stuff. Everything we do pretty much in C++, pretty much everything's done is done within a context of some sort, and that's called a context. And of course the language supports pretty much an endless number of contexts these days. Of course the Arduino has its limitations, with how much context or how much code you can put in. But the language has the ability to have a lot of different contexts. And so that's one thing that I think people should, or someone trying to learn this language should understand first. It's very contextual, this language. And that context is almost always contained in a set of curly brackets. And then, of course, you can have contexts within context, and of course you can build upon that. And that's where it starts to get confusing, and that's where people get lost, and all this stuff. I can say this context contains all these things to do, and they have their own context. And the tricky thing about C++ is that whatever's going on in this context here, this area of I wanted to do something within these brackets, 10 lines of code to do things, tell it to go off and do something, or tell it to store some numbers or calculate some data or whatever I'm doing here. The odd thing about C++, and it's actually a good thing, is that whatever's going on in this context, let's say on line 5, if I had stuff in there, everything inside context here on line 7, because it's a different context, normally it can't see anything that happened in line 5. And that's good for Arduinos because we have limited RAM, we have limited programming space and stuff. So I can create a context and tell it to calculate pi to the 5700th digit or something, which would tax the memory of the Arduino. And then when I'm done, maybe the only thing we need is the result. So we can do all this complicated math and eat up all the RAM and do all these things in the device, and then as soon as it sees this closing bracket for the context, it dumps it. It's gone. It erases it. There's complicated things, the memory manager in C++, the stack and the heap and all this. I'm not going to get into all that right now. But that's basically what it does. So we can use that to our advantage, especially in Arduino. So I think it's important when you're programming any little controller or microcontroller or something that has limited resources, always try to keep things in a context that doesn't get out of hand. If I had one context that was just huge and had a whole bunch of things going on, the problem is you run out of RAM, you run out of memory space. So it's good to have smaller contexts, do something, and only retain the results of that something to then move on. So that's important. So how do we share information between these contexts? Let's say this context calculates something, and then this one wants to use that data. Well, what we do is we simply put our code, let's say we want to assign a value to the variable x, like most programming languages let you use variables, and you can set a number value to the letter x, and x is now 17 all throughout your program, or whatever value you assign to it, or you can increment it, decrement it, add to it. If you set it out here outside the context, everything below this, or everything within this context, can see it. So if x is sitting out here, if the variable x with its value is sitting out here, everything in here will be able to see it, everything here will be able to see it, everything here will be able to see it, everything here. So all of these different areas of code that you write, or contexts, will see this. But if you were to set it here, inside one of these contexts, now if I set the variable x to 17, and once it jumps down here and starts running code here, it doesn't know what x is anymore. It has no idea, because it dumps it. It dumps everything you did. So the only way to share, obviously, something between contexts is to have the result, or what you want to share, outside of the context brackets. And you can have that inside a larger context, and then have, when this whole sequence done, it dumps it there. So that's very important to know about the programming language. If you can't wrap your head around that first and foremost, you'll never be able to read anybody's code. You'll never get very far in the language, because functions and all these advanced features rely on context. So that's what I would tell people, tell someone first. Next is the fact that we can name these contexts, and that's where it gets interesting. I can say here that this is let's just call this an object. Let's call it a ball. This is the context of a ball, and I have a position of x. I give it a coordinate in 2D space, maybe draw it on a screen somewhere. A coordinate of y, and maybe that's 33. I just made a number up. So now we have a context called ball, and it has two variables that we preset to 17 and 33 in this case. Of course, anything we do in here, let's say we want to move to the right. That context will move it to the right. And then we want to move to the left. That context will move the ball to the left, of course. What are we going to do to get it to go to the right? We're going to add position equals itself plus 1, just for arbitrary sake. So that would move the ball one position to the right. And then, of course, we want to do the same thing to move it to the left, except that we want to subtract 1. Minus 1. Move to the left. Seems pretty good to me. Now, this would obviously be called a function at this point. A function is something that takes data in and produces data out. Now, in C++, this code won't work like it is, because the programming language requires a little more information than just simply saying, hey, here's a name and here's what I want it to do. It requires what kind of data do I need to send to it, and what kind of data am I going to get back. You always have to define the kind of data, and that's what's missing here. You'll see that in line 4, I have a position X and position Y. The computer doesn't know what position X means or what kind of data it is. Is it a small value that only takes up 1 memory space? Is it a large value that takes up 4 memory spaces? Or is it a huge value that takes up 1,000 memory spaces? Is it text data? Is it a number? Is it a positive or negative number? Is it able to go positive or negative? The type of data is as important as the name of what you give it. So in this case, we're just going to call it an integer. It's defined as int in C++. Integer means it's a 0 to. It's usually on most programming languages in these days, integer is 16-bit or 32-bit, depending on what processor you have and what kind of computer and all this. In Arduinos, I think they default that to 16-bit data, which is a value or a number from 0 to 32,767, I think it is, and then it's positive or negative. Which, if we had it on a screen, negative wouldn't be off the screen somewhere. So if we want to make it positive, then we go, for Arduino, we have this U, we stick a U in there for unsigned, and then we say that's a type. So now we have a U, unsigned integer of type, position X. Now that I did not, this word right here comes from the Arduino library. You can look it up, and it will tell you what it's defined as. I think that's a terrible name for that kind of data, but I'm not the guy who created the language. So that's how we get the uint8 or uint16 or uint32. We can say it's 8-bit would be 0 to 255, 16-bit would be 0 to 65535, it'd be unsigned, and 32 would be 0 to 4 point something million or some crazy high number, 3 point something million, I think. So we can we can say what kind of data and how big the data really is, or how big the number can be or can get. That also sets how many storage spaces in memory the number is, how much, the size of the memory, because UINT 8 is 1 byte of memory. INT or UINT 16 is 2 bytes. INT 32 is 4 bytes, and INT 64 actually is 8 bytes. So you use a big chunk of data, for one number. You don't want to use big chunks of data if you're only using a number from 0 to 10. You want to use the smallest possible, because in Arduino you want to save resources. So it's important to define your data. And of course, to make an actual function out of this, to make it actually run and not give us an error, we need to define what move to the right is going to give us back and what it's going to eat. I kind of equate it to a function like a small animal, right? That's because I like to think crazy. A function is like a small animal. You feed it something, it goes in its mouth, and then it digests it, does something with it, and then it poops out something back in the back end. That's how a function works. And ironically, the people who wrote or created the C++ language, for some ungodly reason, the first thing you have to define is what kind of data am I going to poop on my function, which is really kind of crazy. And if you're not going to poop any data out, you don't need anything back. You're just going to go perform a task. Like in this case, we're going to add 1 to the position of X. So we don't need any data back. You have to specify no data by saying the word void, void, which it's in the void. I don't need anything back, which is crazy. But that's how they made the language, so that's how we learn it. And of course, that gives me that defines what kind of information I'm getting back from this function, what it's going to poop. How do you tell it what you want it to eat, or what you're going to feed it? And how you do that is with a set of brackets, regular parentheses, right at the end of the name. Move to the right, parenthesis. And when you're defining the function, what you need the function to eat, or what it requires, you put inside those brackets. And of course, when it exits, it's going to give you this kind of data back. If I needed to give me an 8-bit value, back, then I could just simply say, give me an 8-bit value back, like that. But obviously we don't need anything here, so I don't need anything. It's just going to do its task. It's going to move the ball to the right 1 position. And of course, what does it need? Well, we can say UINT8T, the type of data. It always requires a type of data. I want it to eat, or I want it to require me to specify how far to the right. How about that? And then of course, I can say plus how far to the right. That gets me a legitimate function in C++, and we will doctor it up to make it look nice. We'll do this right here. Now this text editor is not great. There we go. So most programming, you'll look at from other people and things will kind of look like this. So now we understand that this is the data type we're going to get back. Obviously nothing. And the name of the function, and then the kind of data it requires, and then the name of that data, whatever we want to call it. And then, inside here we perform some action.